Now we go to the last panel of the event. It's panel 6 of today, Energy Transition and Digitalization, Connecting the Dots. And our moderator is Vaseem Khan, who is Global Vice President, Digital and Analytics with McDermott. Vaseem, over to you.
Greetings, everyone from Houston, and thank you very much for the introduction. So, as mentioned, I'm with McDermott. We are a capital project delivery company. My role is running the global analytics and digital group. My career over 30 years has spanned engineering, construction management, regional management, project management, and running engineering globally for McDermott. So I have seen ups and downs in the industry, and for many of the younger colleagues joining today, I would like to assure you that in my case, this is crisis number 4. And like the other 3, this too will pass. So today's topic is energy transition and digitalization. So before I introduce my esteemed panelists, just a little bit about the subject. So we've been hearing over the past couple of years, especially over the past couple of months, how new energy transition is going to overtake the traditional hydrocarbon industry, and that the industry is in terminal decline and we should all focus on new technologies. So I would postulate here that hydrocarbon energy and new energies, energy transition, will cohabit for many, many decades. Is that these two, and actually there should be 3, because there's hydrocarbon, there are the new energies, wind, solar, hydrogen, but there's also nuclear and hydroelectric. So these sources of energy will cohabit for many decades to come. And we should think of them as complementary and not subtractive. So one does not have to lose for the other to gain. To focus on today's subject, so digitalization. So I think we should all ask ourselves the question, that is digitalization the new frontier? Or is it just a Wild West with many people coming up with many products, many of which will not really be accretive to the bottom line? We've spent billions on digitalization, and we will spend billions more. And we need to see, we need to ask the question, are we spending money wisely? We also as an industry, and I'm talking about the energy industry, need to embrace new energies, and we need to embrace digitalization. So over the course of the next 30, 40 minutes, and we'd like to leave the last 10, 15 minutes for questions that the audience might have, we'll discuss these topics with 4 really specialists in their fields. I'll quickly introduce their names, and I'll ask all of them to introduce themselves in the same order that I'll introduce them. So we've got Noorddin from BP, we've got Richard Zhang from Shell, we've got Patak from Intel, and we've got James Wagstaff from PowerAdvocate. So if we could just do a quick round of introductions, and Noorddin, if we could start with yourself, please.
Hello, everyone. Glad to be here. My name is Noorddin. I've been in oil and gas for approximately 14 years. At BP, I'm part of digital customer products team, which is part of innovation and engineering organization. I'm responsible for architecture design to support the core operations, which is bread and butter for our industry, and also exploring new technology to see if they can be deployed in operations to improve our current business operations, as well as to create new business models to drive new source of revenue, as well as to digitize the core. So that's much about me, and we can go to the next panelist.
Thank you.
Okay, hi everyone, great to be here. My name is Richard Zan. I'm the software product development lead at Zan Hydrogen. My role has been quite interesting because we're at the front and center of trying to realize hydrogen as a nascent business. It's also extra challenging because as a traditional oil and gas company trying to adventure in the new energy space, very much like Vaseem just described, is this a new frontier or is it the Wild West? And it's been very interesting trying to observe how the market leaders has been evolving, what's their role in kind of charting the path for this latest wave of the hydrogen hype. For me personally, we have been building up the internal digital platform, working with our vendors and partners to make sure we have direct access to data, and then figure out what does data mean to us. That is me.
Thank you.
That's
Thank you very much, Richard. Over to you, Manas.
Good afternoon, good evening, everyone. I am Manas Patak. I'm Global AI Lead for Oil and Gas at Intel Corporation. I work with our partners and customers to bring Intel technologies in oil and gas, from AI to intelligent IoT to edge computing. And as the industry is transitioning into becoming an integrated energy industry, we believe that these digital technologies would be the key enabler for this transition. So we are helping our partners and the industry to help them do this transition to a greener, more renewable energy in general.
Thank you. Thank you very much. James, last but not least.
Thanks, Vaseem. I'm James Wagstaff with PowerAdvocate. I'm responsible for the growth strategy team at PowerAdvocate, which means that I look after the organization that aligns client needs in the market, particularly in the digitalization and cost management space, with the data solutions we have at PowerAdvocate. I've been with our organization 11 years and have about a 15-year tenure in the energy industry.
Thank you very much, James. So let's jump in. So energy transition. So I would put it to you, Noorddin, that energy transition, wind, solar, hydrogen, is born digital native. It is like the teenagers of today. It has grown up in an era of digital. So the question for you, Noorddin, is how can digitalization improve energy production using the new technologies that we have in adjacent industries, both in the energy transition space and the more traditional hydrocarbon sourced energy space?
Okay, thanks for the question. So I'm going to cover this. I will break this into three different areas where digital plays a key role. The first one is optimization of energy usage. The second one is integrating different sources of energy. And the third one is the using or digitizing the core business. So energy transition, just like I said, we have mix of energies today, different sources of energy. We have solar, we have hydrogen, we have wind power, and of course, our traditional form of energy, which is hydrocarbon. So what I would say, the growth of the energy usage has been growing proportionally to the GDP growth. In future, it looks like it's still going to grow, but the new form of energy that we are now, the wind power, the solar power, more electrification of a lot of things, is more efficient. We need less energy to do things which we used to do with a lot of the sources that we used to have before. So it's the demand for energy is still going to grow, but the energy requirement may not be grow proportional to the growth. So how do we capitalize on different sources of energy? So that's where the integration plays a key role, and the technology plays a role to integrate different source of energy from source to the consumer, so that we can optimally take the energy from different sources. And if one source of energy is not available, for example, the wind energy is not available, if the wind is not blowing, we should have a way to store energy. So battery technology plays a role. The sun, if sun is shining, we have solar energy, but if sun is not there in any area, the other important key topic that we need to consider is this renewable energy, or the new source of energy, is distributed. It's localized. It's not centralized. So connecting this localized energy and create a central source and distribute energy to the consumer, digital plays a key role there. So going back to the current core operations, the oil and gas operations, where optimization is where we're going to drive a lot of efficiencies. And technologies like IoT sensors, AI, machine learning, digital twin, those technologies play a key role to optimize the maintenance of the equipment, the platform or the refinery equipment. It will optimize predictive maintenance. More, you can predict more versus regular maintenance that you normally do. So you would minimize the maintenance, and you will do maintenance effort only when it's required, or you will get a warning based on the machine learning model when the equipment is expected to fail. So you only go and do the maintenance versus a routine maintenance we normally do. And if you look at the other areas like distribution or logistics process for oil and gas, when you have an oil in the downstream area, when you have an oil at the terminal and you wanted to distribute to the service stations, the route optimizations and all those kind of things where you can deliver the product when it's needed, technology plays a key role. The blockchain technology would also play a role where you can create the provenance of the product when it's created, so that we avoid any risk or any safety issues of dilution of the product from the source until it's consumed at the service station. So that area. And then what I would also like to say is creating new business from digital is also very important. New technologies that's coming in. Oil and gas companies inherently has a lot of customer. They have distribution channels. Those can be capitalized and use the customers to deliver, identify adjacencies in our business processes and create new business model so that it will increase your new revenue stream, it create new revenue stream, and optimize, take the technologies after it's mature and use it into a core business to optimize the current business.
Thank you, Noorddin. That was a very interesting response. I especially liked your response or your discussion on blockchain and how it can be used for the provenance of a product, especially when products change hands multiple times before they reach the end user or the consumer. So Manas, a similar question to you, but from an Intel perspective, from a technology provider perspective, in terms of the energy transition market, how can, from an Intel perspective, technology improve, lower the cost, improve the availability of energy?
Thanks. So I'm just going to follow up on what Noorddin said with like a specific AI examples on each of those categories, so that we have more deep dive into how AI and analytics and machine learning and in general digitalization can help increase the efficiency and can be an enabler for transitioning from oil and gas energy source to an integrated energy source. So let's deep dive into two categories. Let's take an example of the renewable sector first. So you have wind turbines, you have wind offshore, and a lot of these wind turbines actually work on a similar environment in offshore, right? So the operating conditions are same. Can we use something like federated learning, which is a process where, without sharing data, you can share the learnings from the data. So you can have an edge compute near the source of data, in this case, offshore wind turbines. But without backhauling all the data back to the cloud, you can have a federated model that can learn how the winds are operating, how the wind turbines are operating, how do we optimize the energy production from those wind turbines, and then finally, when the maintenance is needed on those wind turbines or wind blades. And if all of those wind turbines can do peer-to-peer machine talking in form of federated learning, then the predictive model is more robust than when it's just built off of 1 or 2 wind turbine. So, this is one way you increase the efficiency of wind turbines in offshore. Let's take an example of oil and gas. Now, you have 10 petabytes of seismic data sitting in a cloud. Doing a manual interpretation of that volume of data is just not possible. So can we have an AI model that's trained on either synthetic seismic data or a lot of real seismic data, and is trained well enough that it can do inference on seismic data, which is a volume of 10 petabytes or more, as if it's flying through the data. So this way you get value of the data that you have already acquired, but it's not humanly possible to go and do the interpretation of that data. So this is certainly what I work with our partners and customers. How do we use AI models, convolutional neural network, which is a part of deep learning, to do these massive scale of interpretation of large seismic volumes. Now, the third category, which Noorddin touched upon, is how do we integrate these energy sources, right? So moving forward, what we're going to see globally is that you will have different feeds of energy coming from different sources. Oil and gas would be one. Then you would have wind, you will have solar, you will have geothermal, hydrogen, and so forth. The grid operators, the folks that provide electricity to our houses, they have very, like a very strong challenge coming up. How do you balance the grid? How do we optimize the grid when you do not know when the sun is gonna not shine, or there would be clouds, or wind is not going to blow? When do you fire up your traditional sources of energy in your power plant, like gas or coal, and make sure that we have consistent supply of energy to the consumers? And that is a very challenging problem that only an AI that is well fed with all the sources of data can perform and help grid operators to balance the grid and the holy grail is automate that whole process and run the grid in a fully automated, optimized way. So that's the three ways, like AI, where it can help in the three categories that Noorddin touched upon.
Okay,
so one more thing I want to.
Yes,
so
please.
sorry, Vaseem, I just wanted to add a comment here. So thanks, Manas. It was very good, explanation of how technology can play a role. One more thing that I wanted to add here is that with all these grid operations and stuff, when we are getting energy from, like I said, the energy is very distributed. A person could have a home and he has a solar panel, so he's localized way of creating solar energy that he can consume. But he may have an excess energy. So there is another way. Digital transformation or digitization will allow you to trade energy with a partner. So if you have an excess energy and someone doesn't have an energy, there could be a platform, digital platform, to trade energy from excess production to the person who doesn't have energy. So there's another opportunity for digital in this space.
Okay, thank you, Noorddin. Absolutely, and a very interesting comment from Manas on federated learning, where we move from a more adversarial to a collaborative approach of data sharing. So thank you for that, Manas. So the next question is slightly different. So we've been hearing a lot about the oil and gas industry being a major contributor to greenhouse gases and to global warming, and that the oil and gas industry will really have to change its way if we are to meet the Paris Accord agreement in terms of limiting temperature rise. So a question to you, James, is where do you see technology, and specifically digital technology, decreasing the carbon footprint of existing technologies or existing production means of energy?
Thanks, Vaseem. It's a great question and a tricky one, as you pointed out. I think maybe the direct response is certainly digitalization has a very important role to play in decarbonization globally, and particularly in the energy space. The way we tend to think about it, and the way our discussions with clients tend to go, is along the framework of kind of scope 1, scope 2, and scope 3 emissions. And operators have traditionally focused the most on scope 1 emissions, which are really directly related to the activities operators undertake. So if you think about an oil field, enhanced oil recovery strategies where carbon is brought into the reservoir is a proven technique that a lot of operators have deployed. And scope 1 is where a lot of the attention it has been historically. Scope 2 emissions for carbon in particular can be a little more challenging in the sense that the traditional thinking around scope 2 is that it's utility related or indirect activities, so electricity or power generation. Again, for an oil and gas operator, there's some proven strategies that we've seen work where, in the case of offshore rigs, for example, electrifying the platforms with solar panels is a strategy. In the case of in the lower 48, for instance, and in shale plays, electric fracking, right? So instead of using diesel, using electricity from solar or wind. For example, in Texas, there's lots of that, and that's a common strategy a lot of operators are thinking about. And then I think the more interesting and more complicated, and perhaps the more nascent component of managing carbon is in scope 3, where you think about the supply chain, the value chain for an oil company, and really how does the company handle carbon and manage carbon and track carbon beyond its own operations. And that's where digitalization, in our view, has the most potential for an impact. And it's because there's so little information available today to operators on carbon in their own supply chains. If you think about the structure, the jacket supporting an offshore platform, that steel and its life cycle is very carbon intensive, from the mining process, the manufacturing process, to the transportation process. There's lots of carbon involved, and there's lots of gains to be made for oil companies who are interested in pursuing net zero strategies by thinking about scope 3. So in our view, digitalization's impacts will be the most significant when they relate to scope 3 carbon emissions, again, the supply chain for oil companies.
Okay, thank you. That was very interesting. So, if I were to summarize this, so the focus today is scope 1 emissions. We need to look at scope 1, 2, and 3. So very interesting. Thank you for that, James. So let's talk about hydrogen. So, recently, especially in Europe, we've heard a lot about hydrogen. France has announced a national hydrogen policy. The EU is encouraging hydrogen. In the north of England, there's a carbon hub being set up, a lot of which will be hydrogen related. So, Richard, talking about both blue hydrogen and green hydrogen, what is the role of digitalization in hydrogen, and how can hydrogen be economically produced by using digital technologies?
Yes. Yeah, very great question, Vaseem. And I also believe last week or 2 weeks ago was the EU's official Hydrogen Week. So indeed, there are a lot of celebration and hype for the current hydrogen market. But to kind of better answer the question of how will digitalization help with this latest hydrogen growth market, is that we need to look back at what we're actually working with, right? We must not lose sight of the fact that the current hydrogen supply chain is still in its nascent phase. And we use that word to indicate many different things, but the top of that is the fact that it is very much of a market that still needs to be shaped and grow from the ground up. And when I think about the nascent supply chains, there are 3 major things that would shape the way of how we are trying to approach to a solution. Number 1 is the fact that since it's very nascent, we're still cultivating the demand with the market, right? So we're still trying to basically educate the public and to show that what hydrogen can really bring on a day-to-day value and also as a business. So that cultivated demand also means that as we increase, one more customer, the next big customer, the market behavior is also ever changing. So that means we have to be able to respond and cope with all of these different changing demands. And as this hydrogen market grows through different phases, the way of how we deal and respond is also going to change. And then the last point of when working with a nascent supply chain is the fact that every day we're trying to explore and validate what is the business model that we can have as a company in the hydrogen space. So for Shell, we have been invested in hydrogen, I think, way back in the 60s, and it has went through multiple up and downs, multiple cycles. The current approach for Shell Hydrogen is that we're investing in the supply chain. And what that means is we kind of act as the investors, and we're trying to cultivate the top vendors globally, who we call them as tier one vendors, and give them the resources and the requirements that we think it will take for them to be able to really fully mature the hydrogen market and be able to make sure that we also hit our business targets. So now if you take that mindset and think about as the kind of supply chain wide investors, what do we bring as a company? In my mind, there are two things that we bring. Number one is the capital, right? The capital generated from the traditional business and trying to really invest in this growing markets. And the second is the safety culture that Shell is very proud of. And it's the kind of same safety mindset that we bring to everywhere from oil fields to Formula One teams. And it's these two things combined together that we use to help the companies grow. So then as we kind of do this sort of investment into the supply chain parts, the big question is, how do we verify that the investment is actually working? And how do we verify the performance and be able to discover supply chain wide insights? And the answer to that is very much data. And that's where digitalization comes in to be a critical player, especially in this early market. So now if you look at what the current market leaders are doing on the supply chain side, most of the company are still hardware focused, right? So they are very much in the mind of just getting the hardware to work, trying to figure out how to get hydrogen to be compressed efficiently. How do we actually reach the kind of system performance requirements? And then the benefit for the supply chain company right now is the fact that they have no legacy software on their back, right? They don't need to actually support legacy software, and it's very much of a blue sky for them to figure out what is the best fit for purpose tool to use. And then so that's the supply chain side. And on the mobility side, we see tons of OEM companies just doing very fantastic market leading software and digital solutions, right? Because they are really the interface to these future customer of hydrogen. And we see Toyota doing this market leading customer acquisition data platform, and all of these companies with the existing market players, they're just focused on how do we improve hydrogen also as a digital experience? Because when we compare with the current market incumbents, the customer right now is going to expect a very good digital experience whenever it's going to a hydrogen station to get fuel or to drive a hydrogen car. So that part is something that is forcing digitalization to be deeper embedded with the business and the market. And that is, we saw as a major drive force to really force the company to think, what does data mean to them at this stage? And then finally on the government side, the regulators and all the different governments who are creating the new hydrogen strategies, as Vaseem has mentioned, there are just lots of reports, right? We have to basically do all kinds of reporting duties, make sure that the data do align. And there are also a lot of innovation happening. So if you position Shell and basically any other company trying to break into the hydrogen market amongst these players, you'll kind of deduce to the fact that we really need to have an open collaboration mindset, right? So it's very much about, it's no longer this is Shell equipment and data is generated and must be kept internally. It's much more about how can we share the data safely and conveniently with all of our partners. And the more that we will be able to get more kind of different experts, different parties to look at those data, the better we'll be able to derive these supply chain wide insights. And then one kind of quick comment regarding the use of data and how do we actually drive value out of data. I think one unique thing for hydrogen is that there's less play on the AI and machine learning at the current stage, very simply because the kind of baseline of all of our data is just not there. Most of these sites have a year, 2 years of data at best, and the fields are still happen sporadically. So very much for the next 2 to 5 years, how we see digitalization play a role is just to accumulate the data and to be able to standardize these new data structures and to really align industry standards around how we will, how much of a role data will really play in this whole supply chain.
Okay, thank you, Richard. And just one question, which is actually triggered by a comment from Stuart Broadley in the chat. I see you've got a car behind you, Richard, a model car
Yes.
behind you. So, aspirationally, should that car be hydrogen driven, or should that car be electric? Is it going to be a Tesla, or is it going to be a hydrogen car? And thank you for the question, Stuart.
That's fantastic. And for those of you who live in California, I actually strongly recommend you to take a test drive from Toyota, Honda, one of those hydrogen EV car dealers. What you'll realize is, to me personally, and this is just speaking for myself, I think hydrogen's experience really represent the future of how mobility should work, right? I personally don't want to have the experience of having to wait to charge my car for a couple hours and to really have that anxiety in terms of how I use my car's energy. And then for hydrogen, I see that as, for me personally, I would rather for that car to be hydrogen, because that means I can fill its tank in less than 5 minutes, and I'll also be able to have that very smooth driving experience. It's very hard to say specifically what's the difference between that and BEV, but it is my personal favorite, so I'll give you that answer.
Richard. So moving on, and I would request that we limit our answers now to 2 or 3 minutes because we are going to run out of time. So a question for James here is, what sort of learnings from the oil and gas digitalization, which has been ongoing for the last decade or so, are transferable to the energy transition industry? And specifically, what did we in oil and gas get right, and what should we do differently? But again, I request that we limit our answers to 2 to 3 minutes because of our time constraints.
Certainly. And I think Richard's comments just now actually are very applicable to this topic and this question. But in particular, as it relates to digitalization in the oil and gas business, we see at my organization, we see supply chain spending across the industry. And there was over the last 5 years, there was a 17% annual growth rate in oil and gas organization spending on digitalization. And you made the point, Vaseem, earlier in the session, that's billions of dollars. So there's a huge rush to spending money on digital solutions and digital products. If you were a marketer to the oil and gas business, having a digital product was very effective in the last few years. But part of the implication of moving so quickly in buying and implementing digital solutions is that organizations were left with huge data problems. There's ERPs, there's well systems, there's maintenance systems, labor systems, all kinds of systems around the business and around the world that create data that needs to be organized and cleansed and aggregated to actually draw insights. And that's where people may have been short-sighted in understanding the magnitude of that challenge. Just thinking about one operator we worked with, there was a departmental survey that the organization conducted, and across all of the FTEs in the department, 40% of the group's time was spent collecting and organizing data just so they could do work and generate reports and provide information to the business. So that's a real challenge, and that's what I would suggest was the industry got wrong historically. Implications for the future, implications for the energy transition, are that there's an opportunity to reflect upon those challenges and actually have a data first strategy. So rather than racing to put new technology systems in place, organizations might be better served by thinking about what are the data needs from this new workflow or from this new technology or this new digital product, and how does that fit with the way we currently manage data, the way that we currently have high quality data, or what do we need to do to make that new undertaking fit with and be clean in terms of the data sets that we require in our business.
Okay, thank you, James. So start with the end in mind. Anything to add to that, Noorddin, from an operator perspective? What would you do differently compared to what BP did previously?
So this is what I would say. I agree with what was just said. But in my view, the things as for the digital transformation, with digital transformation, our industry in the past has been very siloed. We share information within the industry, but with digital transformation, it's creating a culture of more collaboration. So somebody said that before, and I have heard this phrase before as well, is that collaboration is a new competition now. So we have to collaborate not within the company, within the industry, but we need to collaborate externally with other technology industry. Our industry, oil and gas industry, used to be heavy industry. Now it's going to be, and it's converting or transitioning into a more technology driven industry. So we have a lot of learning that we have learned as a part of digital transformation, as well as we still have to continue to learn from the technology company and bring those learnings within the organization. So collaboration is one, not only within the industry, but externally as well with other industry. The second thing, and I want to, piggyback on what was just said about the data. In my view, the data is a new oil. We have a lot of data. Now technology has improved, the compute power has improved. So we are able to process huge million terabytes of data, and we are able to get an insight from that data and then use that insight to improve our processes, and help with energy transition to deliver affordable, reliable, cleaner energy to our customer. So those are the point. And then one I would say one item across the data element is that we keep different ontology of data in different systems. And if Manas would probably be able to, elaborate more on that, that if you have a machine learning model or you want to use AI, the data has to be synchronized so that you can use the power of data to predict or make changes to the system.
Okay.
So data synchronization, collaboration.
Thank you, Noorddin. So if I were to summarize this, start with the end in mind and a collaborative partnership approach rather than trying to go it alone. So coming up to the last question, and I'll ask Manas and Richard this question, is, and we talked about this earlier, will digitalization move the industry to a more decentralized energy delivery model? Small, more local but connected facilities rather than large centralized facilities. So from an IT, from a computing perspective, Manas, your thoughts on that? And again, if we could limit our answers to 3 minutes so we can do a quick wrap up as well.
Absolutely. And let me begin with what's fundamentally changing. So fundamentally, a consumer who was consuming electricity or energy is turning into a prosumer, meaning it's consuming, but it's also producing, such as I have a rooftop solar above me, right? So I can create energy as well. And when I create excess energy, I need to transact it with the grid. I cannot store energy, so can I give back to the grid? Similarly, we have Intel campuses in US, and many of them have parking lot solar. So they are producing energy through the solar cells that are laid out across all the parking lots in Intel. So this poses a fundamental problem to the grid operators. When the grids were laid out back in century, they were laid out keeping in mind that there would be one direction of flow of electrons. You produce these electricity or energy in these beefy power plants that are powered by coal, nuclear, gas, and then you send it to the consumers like us. Now it's changing, right? The consumers are also producing. Not only that, instead of a very predictable demand of energy that could be sufficed by these beefier power plants, is replaced by these unreliable yet important energy sources like solar and wind. So this changes the fundamental way we need to think about how the future of electricity is going to look like, and the transition is going to look like. You would have a decentralized model. You would need these substations near the prosumers. That's only job would be to balance the grid. Can I sell back my excess electricity when the sun is shining in Phoenix, where I stay, at 12 noon, to the grid, or to the nearby consumers who need more electricity at that time? So to answer your question, yes, the decentralization is imminent and it's going to happen. And the only problem is that we need to revamp our grid. The traditional grid is not able to have two-way flow of electrons perfectly possible. So we need to change that grid into a new modern grid, and with that, the decentralized energy future is very close.
Okay, thank you very much, Manas. So Manas's vote is for decentralization. So Richard, I mean, hydrogen actually lends itself to more local, because hydrogen in its elemental form is difficult to transport. So what are your thoughts on that? Is the future decentralized energy provision two-way, as Manas said, energy coming in and out of a decentralized model?
Yeah, I would definitely say that we do believe in the future of distributed hydrogen generation. And I really want to echo the comment that the kind of localization and decentralization of energy generation, it will be the future. At the current strategy level, we do have kind of planned central capacity, right? Where in Europe we'll have reused natural gas pipeline to transport hydrogen. So there are gigawatts projects like that that will still try to offset the lack of capacity from your local or microgrid. But at the same time, we do see much more market development around how will hydrogen play a role in the ever more growing microgrids, and especially when it comes to integration with the different local demand response program. And what that has driven as a technical requirement is that it means we need to have more LT deployed and a lot more offline first software situation. So essentially you couldn't rely on these hydrogen software solution to have internet connection at all time. They need to be able to kind of respond to emergency usage as well. And kind of that really also set the scene for the need for hydrogen digitalization and software to be able to evolve at the market speed rather than being tied to one specific solution. And it really also speaks to the need for hydrogen to be in that kind of unique position, work with all these different players, and also try to figure out what's the best solution when it comes to software and hydrogen.
Thank you. Very interesting. So I think the summarized conclusion would be we are moving towards, the energy transition is moving us towards a more decentralized, localized grid system. But as pointed out by Manas, it will need us to re-engineer how we distribute electricity. So I'd like to thank all of our panelists. I'm going to just address one question, and because it's very interesting. It's from Stuart Broadley, and it builds on what Dr. Edwards talked about earlier about Australia. And I think the question broadly says, is a geography, a company, or a culture which is more digital more likely to embrace energy transition than the other way around? So that's a very interesting question, Stuart. And in the interest of time, I'm going to let James take a quick stab at this, and then we'll close after that. So again, in the interest of time, I want to thank all of our panelists. I want to thank all the audience for participating, and I'd also like to thank the organizers for this really interesting conference. So, James, if you could just, from your consulting perspective, does a geography more attuned to digital technologies also facilitate energy transition?
Thanks, Vaseem, and I appreciate your repeating the question as well. I heard you originally, and then was hoping I'd get a second play of it. It is a great question, and I think it asked originally about geography, but also culture, and maybe taking that to a company particular lens versus a geography. I think it's a fascinating concept, and I actually agree that there is a correlation in the sense that the energy transition and even digitalization is largely associated with a faster rate of change in a long-standing and historically slow-moving industry. Organizations and teams of people that are digitally minded, analytically oriented, and comfortable with working with data sets and new information are better suited and better positioned to be successful in an environment that has a higher rate of change. And so I think that the two are very complementary in the sense that business models are changing rapidly. Of the organizations represented on this phone call or on this panel, they've all announced very significant changes in their futures and the portfolios they'll be managing. And so it's exactly the case that the teams that have comfort level in working with digital technologies, new technologies, are going to be successful working on new projects and in new asset classes.
Thank you very much. Just to close this out, just a parting thought from my side, my personal opinion is that the hydrocarbon energy, renewables today, nuclear, the new energies, they all have a space. They will all cohabit for many decades to come. All of these need to be more efficient in terms of how they deliver energy. And I think the key to this efficiency is going to be the use of digital technologies, use of digitalization. So with that, I'm going to hand back to Adam. And again, thank you, Future Oil and Gas, for arranging an excellent conference.